Picture this. You're an engineer working in a factory that manufactures complex machine parts. You're responsible for ensuring that each part is precisely machined to the right specifications. 1 millimeter off and the entire assembly could fail, but there's a problem. The sheer volume of parts you need to measure, combined with the intricate geometries of some components, make it almost impossible to keep up with the pace of production. What if there was a way to automate this process? What if a machine could not only take precise measurements, but also learn from its mistakes, continuously improving its accuracy over time? Enter the world of artificial intelligence in metrology. Artificial intelligence, or AI, has emerged as a game-changing technology in numerous fields, and metrology is no exception. According to a recent paper published in Measurement, AI is now being used in coordinate metrology to select measurement strategies, conditions, and filtering techniques. Now, what does this mean? In simple terms, coordinate metrology is the science of measuring the physical geometries of an object in three-dimensional space. Traditionally, this has been a labor-intensive process requiring skilled operators and meticulous attention to detail. But with AI, it's possible to automate much of this work, freeing up engineers to focus on other tasks. AI can not only perform measurements, but also self-verify and self-calibrate. This means that it can check its own work, identify errors, and adjust its parameters to improve accuracy. This is a major breakthrough, as it significantly reduces the potential for human error and increases the overall efficiency of the measurement process. The paper also discusses the application of machine learning, a subset of AI, in interferometry. Interferometry is a technique used to measure small displacements, refractive index changes, and surface irregularities. It's a critical tool in many areas of science and engineering, including optics, seismology, and astronomy. But like coordinate metrology, interferometry can be time-consuming and complicated. Machine learning can simplify this process by analyzing interference patterns and making accurate measurements. However, one of the challenges here is collecting sufficient data for AI applications in measuring industrial parts. In addition to these advancements, AI is also being utilized in identifying modal mass in structural modal testing, estimating parameters in split functional models, classifying intense winds in mountainous terrain, and improving the morphological transform filter for fault current analysis. In summary, the integration of AI in metrology is revolutionizing the way we measure and analyze the physical world. By automating complex tasks, improving accuracy, and learning from its own mistakes, AI is not only transforming metrology, but also paving the way for more efficient manufacturing processes. The future of metrology is here, and it's powered by artificial intelligence. The technology has its challenges, but as it continues to evolve and improve, its potential applications in metrology and beyond are almost limitless. So, next time you're working on a complex machine part, remember that you're not alone. AI is here to help, and it's changing the game in ways we're only beginning to understand. As we